Hello students, welcome to video session. Let's learn something new today. Students, uh, in the previous slide, in the previous video session, we have learned about unit conversions of length, area, force, and stress. And also in the previous class, I said that I'll be dealing with the problems in the upcoming classes. So today, let's start with the problems. Let's see the first problem. The question is a steel rod 25 mm in diameter, 200 mm long, extends by 0.25 mm under tensile load of 40 kilonewton. Find stress, strain, and elastic constant. So this is what the question. Students, first carefully understand the question, and after understanding the question, just analyze. Then you try to write the given values. So first, I'll write the given values. Once again, I'll read out the question so that I can write the given values. A steel rod of 25 mm in diameter. So here he has mentioned diameter is 25 mm. So that is nothing but D is equals to 25 mm. Okay. Next, 200 mm long. Long is nothing but length. So length is equals to 200 mm. L is equals to 200 mm. Then 200 mm long extends by 0.25 mm. He is telling that extends is nothing but increase. So students, whatever it may be, either increase or decrease, it may be, we should take it as a delta L, change in length. That is nothing but delta L is equals to 0.25 mm. So delta is nothing but change in length is equals to 0.25 mm. Okay, well, under tensile load, this is nothing but a load of 40 kilonewton. So load is nothing but P is equals to 40 kilonewton. Next, what he has asked, he has asked us to find stress, strain, and elastic constant. So stress, F is nothing but stress, that's what we need to find. So F equals to question mark, and then strain is nothing but E small e, we need to find. So E equals to question mark, and elastic constant, that is capital E. So that capital E is nothing but elastic constant, I mean Young's modulus. We need to calculate this. Students, this is the given data. Before going to the problem, before solving the problem, first just look into the given data. Just analyze whether unit conversions is necessary or not. It's very important. After reading the question, try to write the given values, and after the writing the given values, first think whether unit conversion is necessary or not. So just just step by step, I'll go through the given data. So D is 25 mm, it is in mm, so no need of conversion. Length is also in mm, 200 mm, there is no need of a conversion. Delta L is 0.25 mm, so there is no need of a conversion. P is equals to 40 kilonewton. So students, we need in terms of Newton, but it is given in terms of kilonewton. So we need to go for the unit conversion. So in the previous classes, we have learned in detail about the unit conversion. So from this, so unit conversion is P equals to 40 into kilo is nothing but 10 power 3 and Newton as it is. This is the conversion. If you are not thorough with the conversion, once again you go with the previous video and practice a number of problems on unit conversion. Once you are thorough with the unit conversion, then try solving the problems. Okay, this is a given data and everything is clear, everything is converted. Now students, you need to solve each and every problem step by step. Students, always you remember, while solving the problems, especially problems related to stress and strain, the first step you need to solve for area. First step, you need to solve for area. Students, this is what I'll write here. The first step you need to solve is for area. area. Okay, the second is stress. Second, you need to solve for stress. Then third is for strain. Then fourth is for Young's modulus. Young's modulus. Students, this is the order you are supposed to follow. It's very important method, students. It's one of the important method. So you know, in order to get your problem correct, then you are supposed to follow this method. First, you solve for area, then stress, strain, Young's modulus. Students, one more thing, first I'll calculate area. Okay, not a problem. Then after completing the area, I need to calculate for stress. By chance if I get answer, then it's okay, good. If I don't get answer for stress, then I should skip the stress and go to the next one, strain. Once I solve for the strain, I need to come back because I have not got the value of a stress. So after getting the strain, I should come back to the stress and check is it possible to calculate or not. If possible, calculate. If not, then once again you skip and go for the Young's modulus. If Young's modulus is done, and if Young's modulus is done, you come back to the stress since it is not solved. So you come back to the stress, and once again you check whether is it possible to solve or not to that extent. If it is yes, you go ahead for solving the answer. If not, then skip and go for the next steps. Okay, students. So next step, I'll go for, since this is a basic problems, whenever you come across problems on engineering constants or elastic constants, next step will be lateral strain. Lateral strain. So next will be Poisson's ratio. Poisson's ratio. So next step will be constants or else engineering constants. So this is the step, students. First you need to go for area, stress, strain, Young's modulus, lateral strain, Poisson's ratio, engineering constants. Just you make this make note of these 7 points in a separate paper. In while solving each and every problem, you go with these steps. Okay, even I'll be following the same steps while solving each and every problem. Okay, students. Okay, done. Okay, so as I said, first I'll go with the area. The formula for the area is pi by 4 into d square. Since he has given the diameter, so my formula becomes pi by 4 into d square. So just check whether can we solve this or not. Can we solve for area or not? Students, how to check? Just think, just go through with the formula where a is unknown. Area is not given in the given data. Area is unknown. So right now we have unknown value, one unknown value. Pi by 4 is a constant. Definitely with the help of a calculator, we can calculate. Then there is one more parameter, that is d, diameter. Just check whether diameter is known or not. Yes, in the given value, we have the value of a diameter. So students, out of this formula, how many unknowns are there? There is one unknown, that is area. If we have one unknown value, if we have one unknown, then we can solve it. If we have two unknowns, then we cannot solve. It's very difficult to solve. Again, we need to check the equation, check the formula whether it can be solved or not. To right now, if you have only one unknown, then you understand it can be solved. Okay, students. Right now, in my formula area, A is unknown. Only there is only one unknown, so we can solve this. So what I'll do, I'll write area as it is equals to pi by 4. Pi by 4 as it is. Multiplication symbol in place of diameter. What's the value of a diameter? The value of a diameter is 25. So 25 square. Next, I'll calculate the values. A is equals to the value of pi by 4 is 0.7853. Students, what I suggest is after decimal, try to take four values, 4 points. Okay, after a decimal, try to take four numbers, four values. Okay, that's why I have taken 7853 into the value of 25 square is 625. It's very simple. With the help of a calculator, on calculating, I'll get area is equals to 490.81 mm square. Students, these units are very important. Even though I get the value of 490, but units are very important. If I miss writing a units, and then definitely I'll lose 1 or 2 marks. So units are very important. Okay, students, right now I got the value of area. Then after area, I need to go for the stress. So the second part is stress. Stress. What the formula for stress? F is equals to P by A. F is stress, P is load, A is area. Again, once again, you cross check, students. Can we solve this stress? See, F is unknown. Do you have any value F? So we need to find F. So F is unknown. We have one unknown value. What about P? Do we know the value of P? Yes, we know the value of P. What about A? Yes, we know the value of A. Right now we have calculated. So how many unknowns are there? There is one unknown. If we have one unknown, then definitely we can solve for that. So write F as it is, equal as it is. What is the value of P? P is nothing but 40 into 10 power 3 Newton. Students, we need to take the converted value. If you take only the 40, then you will end up with the error. So always you are supposed to take a converted value. So P is nothing but 40 into 10 power 3 divided by, then A is nothing but area. Area is 490.81. So with the help of a calculator on calculation, we get the value of stress is F equals to 81.49 Newton per mm square. Newton per mm square is a unit of a stress. It's one of the very important unit. Okay, students, is it clear? Once calculating the stress, what's the next step? Initially, I have given 7 points, 7 steps. First is area, next is stress, then third is definitely yes, it is strain. Strain is equals to E equals to delta L by L. E equals to delta L by L. Students, once again, analyze whether can we solve for strain. So just E is nothing but strain. E is unknown. Yes, E is unknown. One unknown value. What about delta L? Yes, delta L is given. What about length? Yes, length is given. So we have only one unknown value. So we can solve for strain. So just substitute the values. E as it is equal delta L is nothing but 0.25. Write 0.25 as it is divided by. So put a division symbol. Then what about length? L is nothing but 200 mm. Right, 200. So on calculation, I get the value of E is equals to 1.25 into 10 power minus 3. What about units? Students, strain has no units. It's very important. Strain has no units. It has only the value that is E equals to 1.25 into 10 power minus 3. Okay. So we have completed with the 3 steps. What's the another step? That is Young's modulus. Young's modulus. The formula for the Young's modulus is E equals to F by E. Students, once you write the formula, what I say is after writing the formula, just check can we solve for that formula or not. So capital E is Young's modulus. It is unknown. Okay, we have one unknown. What about stress? We have the value. What about strain, small e? Yes, we have the value. So we have one unknown. Then we can solve the problem. So we can solve that for formula. E as it is, equal as it is. Stress is nothing but 81.49. What about strain? So 1.25 into 10 power minus 3. On calculation, I'll get the value of E equals to 65.19 into 10 power 3 Newton per mm square. That is a unit for Young's modulus. Okay, students. So finally, we got all the values. Even the question has asked us to find stress. We have got the value of stress. Strain, we got the value of strain. Young's modulus, we got the value of Young's modulus. That's it. Students, it's very simple. Especially problems in strength of materials are very simple problems. Okay. I think it's this problem. This question is very clear to you. And now let's move on to the next question. Students, this is the next. This is a question which is on the screen. Students, let me read out the question. What the question says is: a load of 5 kilonewton is to be raised with help of a steel wire. Okay. Find the diameter of a steel wire if the stress is not to exceed 100 megapascal. This is the given question. Okay. Okay, done. After reading the question, just try to write down the given data. That's one of the very important thing. So writing the given data correctly is one of the important step. So first, a load of 5 kilonewton, that is nothing but load is nothing but P. P equals to 5 kilonewton, okay, is to be raised with the help of a steel wire. Okay, done. Find the diameter of a steel wire. Find the diameter of a steel wire. And I mean, he is asking us to find the diameter. So that is nothing but D is equals to question mark. If the stress is not to exceed 100 megapascal, is telling that stress should not exceed 100 megapascal, it means the value of stress is 100 megapascal. Simple. Okay, that's what the question is. Okay, is there any other data given? No, this is what the data he has given. Now, first you go through with the given data whether the unit conversion is required or not. So in case of P, we need to convert the units. So conversion becomes P equals to 5 into kilo is nothing but 10 power 3 Newton as it is. What about megapascal? Definitely we need to go for the conversion. F equals to 100 Newton per mm square. Students, I'll tell you the shortcut. In the previous class, I have explained you how to convert this megapascal. uh, I have explained you around 4 to 5 steps in order to get the final answer. There's one more very shortcut, students. If it is megapascal, students, remember this. If it is a megapascal, then you keep as it is without any conversion, without any change in value. Students, F is equals to 100 megapascal. Here it is a megapascal. So final answer will be 100 is 100 itself. 100 itself. If it is gigapascal, then the answer will become 100 into 10 power 3. That is the changes. So I'll explain you once again when we come across with the giga. Right now it is megapascal. In case of megapascal, without any change in value, you put as it is. Okay? Okay, done. As usual, first step, we need to go for area. A equals to pi by 4 into d square. As usual, again cross check, can we solve for area or not. With this analysis, there is only one parameter, only one unknown parameter, so we can solve for area. Is it right? No, there are two unknowns. There are two unknowns. So that's why, students, you need to be very careful. In the previous problem, we came across an area where we had only one unknown, so we got the solution for area. But in this problem, we have two unknowns for area. That is, A is unknown and D is also unknown, so we cannot solve for area. What I should do? Simple, just skip the area and go to the next step. Next step is stress. What's the formula for stress? Stress equals to F equals to P by A. Again, you analyze. See, students, how important it is to analyze whether can we solve that formula or not. F is known. Yes, F it is known. What about P? Yes, P is also known. What about area? Area is unknown. We have only one unknown, so we can solve. Definitely. F, in place of F, put 100 equal as it is. In place of P, write 5 into 10 power 3 and divided by A. A is unknown, write A as it is. Just on simple cross multiplication, I get A equals to 5 into 10 power 3 divided by 100. Just on simple cross multiplication, just A will go here and 100 will come here. Very simple cross multiplication, which you have learned in the school days. With calculation, with the help of a calculator, I'll find the area equals to 50 mm square. 50 mm square. Okay, students, once I'll get the value of area, you go back to the area. Don't go to the next step. First go back to the previous one, and again you cross check whether can we solve or not. If it is possible to solve, then go ahead to solve that area. If not, again you skip and go to the next step. So I'll go back to the area. So area is equals to pi by 4 into d square. Area is nothing but 50 is equals to pi by 4, right? Is as it is into d square as it is. Next, 50 is equals to pi by 4. Value of pi by 4 is 0.7853 into d square. On simple cross multiplication, I'll get 50 divided by 0.7853 is equals to d square. So finally, I'll get d square is equals to 63.69. Students, is it clear? On simple cross multiplication, I'll get this step 50 divided by 0.7853 equals to d square. So finally, on calculation, this one 50 by 0.7853, I'll get 63.69. Since I need only the value of d, but I have d square, so square becomes square root. When square shifts to the another side, it becomes a square root. So d is equals to square root of 63.69. So on calculation, I'll get the value of d is equals to 7.98 mm. This is your answer. This is a answer for diameter. Okay, students, is it clear? This is very simple problem, students. These are the very basic problems, students. Just you go through these two problems. In the next video, I'll be dealing with slight complicated problems. I'll then later I'll start with the problems on elastic constants. I mean engineering constants. Okay. Okay, this is the end of the class.